Hey everybody, Mr. Troy here. Got a quick video for you on how to find the determinant of a 4 by 4 matrix. Okay, so we're going to start with these definitions here. Let me blow them up for you. So the first is a more general definition of a determinant. And what it says is that if you expand on the first row, so that's why these all start with ones, of a matrix, that you can find the determinant by taking those elements, so 1, 2, 6, and -3, and then multiplying them by the cofactors. Okay, so the cofactor is found by taking the matrix that excludes that row and the column of that element. Okay, so in the case of 1, that would be this little guy here, 2, 1, -4, 3, 2, 1, 1, 0, -1. In the case of 2, that would be this matrix. So 0, 1, -4, -1, 2, 1, 4, 0, -1. For 6, it would be this one, 0, 2, -4, -1, 3, 1, and 4, 1, -1. And then for -3, it would be this, 0, 2, 1, -1, 3, 2, and 4, 1, 0. Now, what this says right here is that you are going to add if the row and column add to an even number. So for the example of 1, that is the first row, first column, so -1 to the first row plus first column is -1 squared, which is +1. So +1 means add. We're then going to subtract if row plus column is odd. So for the example of the 2 here, it's in the first row but the second column. So -1 to the 1 plus 2 is -1 to the third, which is -1. So we're going to subtract. So we're going to add this, subtract, add, and subtract. Now here's the cool thing. The cool thing is that you can do this to any row or any column. So what you want to do is you want to pick a row or column that has zeros in it, if that is a possibility. Okay, so let's try and put that into action. Instead of using this, where I have to find 4 3x3 determinants, let's go ahead and let's expand on the bottom row to see how that would work, because the bottom row has a 0 in it. Okay, I'm going to start out by writing out the elements of the bottom row. Then I'm going to have to figure out if those are positive or negative, if they are adding or subtracting. So this 4 is in the 4th row, first column. That adds to 5, which is odd, which means I'm going to have to subtract. Here, this is the 4th row, second column. That adds to 6. That's even. So I'm going to add. 4th row, third column. That adds to 7. That's odd. So I'm going to subtract, but it doesn't matter. And then 4th row, 4th column. That adds to 8. So I'm going to add. So I'm going to be adding a -1. Now, what am I going to be adding? Well, I'm going to be adding this 3x3 determinant set. I'm going to write them in and then talk about them. Okay, so I've written in the matrices for the 4 which we're subtracting, I'm using this matrix, 2, 6, -3, 2, 1, -4, 3, 2, 1. For the 1 which I'm adding, I'm using this 3 by 3 matrix. I don't care about the 0 because it's a 0, so I'm not even going to bother writing it down. And for the -1 that I'm adding, 1, 2, 6, 0, 2, 1, -1, 3, 2. Okay, I noticed the tiniest mistake here. I had a +1 instead of a -1, so let's make sure we fix that. Okay, now I'm just going to use either, the 3 by 3 determinant method that we learned last video, or what you're much more likely to do is you're much more likely to use the shortcut method to find your determinant. So none of these determinants are that bad, but there does get to a point where, gosh, you wish there weren't so many of them. That's why we like the zeros so much. So, you love to save time where you can. So we've got 2. And then this is going to be -72. And -3 times 2 times 2 is -12. So 2 minus 84, that's -82. Minus, going in the opposite direction, that'd be -9 plus -16 plus, looks like 12. So minus -13 would give us negative, I think -69 here. So -4 times -69. And then the other 2, I'm just going to write in to save you a little bit of time. So +1 times 30 minus 1 times. And when you add all of that up, you get a determinant of 295. Okay, so that is how you do a 4 by 4 matrix. Super fun. Hope that was helpful. Talk to you later.